And now it's time for A Geek Speak with
GK Technologies,
Sarah and Jodi.
In the fields again. I just can't wait to get in the fields again. The life I love is spreading potash for my friends, and I can't wait to get in the fields again. No, I can't wait to get in the fields again.
Welcome back to A Geek Speak. And with us, we are going to continue our conversation with Professor Emeritus, Dr. R.J. Goose. He retired from NDSU
a couple years ago.
And we had such a really great conversation in the last episode. If you missed it, I highly encourage you to go back and check it out. Lots of fun, totally geeking out about a lot of stuff in that one. On this episode, we had finished up previously starting to talk about iron deficiency chlorosis. And certainly, Dr. Goose, you have spent a lot of your career working on iron chlorosis. It would be remiss of us not to spend a little bit more time talking about that. Iron chlorosis is one of those nutrient deficiencies that gets managed by precision agriculture very well because it changes over the landscape so much. And so let's just start there. What's your overall general idea of how you see precision agriculture management with iron chlorosis?
Well, IDC, it's different now than it was. It's different and it's not different than it was 20 some years ago. 20 years ago, soybeans were new in this part of the country. Farmers were just learning where the chlorotic areas are. And I think soybeans have been grown in rotations enough where farmers pretty much know, in general, where the chlorotic areas are. It's always funny, whenever I would approach a farmer to say, can I have an IDC experiment on this particular piece of land, maybe on this part of a quarter section, the farmer would always say the following. Well, if you think that area is bad. So the farmers know where the bad areas are now, and they know in general where the bad areas are. Now, sometimes that information gets lost when the land changes hands or a new renter comes in. I've seen fields that were abandoned from growing soybeans because the IDC was so bad. A new renter comes in. What's the first thing they plant?
Soybeans.
Soybeans, yeah. So, but for the most part, farmers know in general where it is. The size of an area can be different from year to year as well. And I'm always asked about this time of year, is it going to be a good or a bad chlorosis year? And right now it's wet, and wet conditions favor chlorosis. But if you have a really dry spring and those salts have been moving up and those salts have been moving, that could be a bad chlorosis year too. So I don't know whether it's going to be a bad chlorosis year. The one thing I do know is that 25 years hence, the problem's as bad as it ever was. I always say chlorosis is as bad as it ever was because the varieties are as bad as they ever were. And hey, we can cast some shade on the seed companies, but then again, it's not an easy thing to breed for. We did those DNA studies 15 years ago, and we found at least 7 associations. Not me; I just provided the seed and the ground truth. Don't even ask me to spell DNA. But anyway, the genomics people said, well, there are 7 genes or associations, they each give a little bit. So it's not like there's a cis gene or it's not like there's a phytophthora gene. There are maybe at least 7 genes that give a little bit. And stacking all of those up isn't easy. But still, when the seed companies are trying to balance all of their trait packages, all of their disease packages, and, if they're trying to get 6 of those 7 associations, that's a very almost impossible breeding challenge. So, yeah, I cast shade on the seed companies, but it's not easy either.
If I could, I do want to highlight that back years ago, you had started the Yellow Soybeans website, and you had done a ton of variety trials back then. And, at the time, I was working in ag retail, and so I was selling seed. I always had the results of those trials not only for the year that I was selling seed in, but for the years prior. Yeah. Because as we alluded to earlier in the conversation, you can have a bad iron chlorosis year one year, or it can be modified year in and year out, depending upon the weather conditions and just what's going on. If somebody was coming in, we'd have the yield results sitting there, so we could take a look at yield, but then we'd have the Dr. Goose's iron chlorosis scores, so we could make good decisions for those situations where we needed them. And I think that revolutionized really how we thought about seed, at least in this area, from an iron chlorosis standpoint.
I still own the domain name, yellowsoybeans.com. And so I don't know. I didn't have much competition for it at the time either. But Carrie Miranda continues that work at NDSU. I'm involved with that, helping her find sites. And, she's trying to increase the number of sites. A problem is, of course, that not every company participates. And I did a bad thing once. I took the lowest ranking varieties on NDSU's trials that were bad across multiple years and sites. And then I went to the website to see what the companies would say about those varieties. And in Lake Wobegon, Minnesota, all of the children are above average, right? And those of you not from the area wouldn't get that joke. But anyway, but these varieties that were terrible, they were all above average on the rating scales of the companies. In fact, some of these companies, if they have a 1 to 9 scale, say, all of their varieties are between 8 and 9. Well, no. Some of them were probably 3s. So marketing gets in the way of agronomy.
To that point, and from somebody who has sold seed, certainly there are places out there where we have to position seed properly for dealing with areas of very severe iron chlorosis. And in those places, we really need to know what those honest ratings are. Yeah. But what I always found out when I was selling seed is that every variety has its strengths and every variety has its weaknesses. Yeah. And there are places around this area where iron chlorosis is not an issue. Yeah. Yes, certainly our parent material is very rich in calcium carbonate, and so it is something that we always have to monitor. But just because a seed variety didn't necessarily have its strength in iron chlorosis doesn't necessarily mean it's a completely bad variety for everywhere. It might have a place someplace else. So I guess if there's any seed companies out there listening, I would certainly hope that just be honest with your rankings and help us understand maybe a better place for that to be, and let's keep it out of the iron chlorosis areas.
Yeah. And then one time I took 8 varieties that were bad. I went to see what the seed company said about it. And one company said, well, actually 2 companies got it right. 2 different companies said, avoid on your chlorotic land. And 4 companies rated it just as average without anything. And 2 companies said good against IDC, So, and I don't know what the issues are. Here's another problem. I had a support group in Colfax, the Colfax Chlorosis Club. Me and the local agronomist and the local county agent, we had a support group, and we would meet twice a year. We would have a winter meeting and then a summer field tour and let the farmers try everything, cover crops, fertilizer, whatever. And one problem that the local agronomists have, the agronomist at the time, she had identified the go-to variety for the hot land. And if there was hot land, that was the variety she recommended. But then the seed companies quit selling it. That's another part that, that I would say to the seed companies, if you got something that really works on IDC, don't be so fast to phase it out. All of your expenses are sunk. It's all profit. You're helping out. Maybe it's a minor thing for the seed company, but it really does help the farmers.
And I mean, it's interesting thinking about IDC specifically as a challenge that we face here. And one of the newer challenges we face now, too, is dealing with SCN. And even it has been in North Dakota since 2001, so very early 2000s. But looking at Peking source of resistance versus the PI 88788, and then not only knowing how strong that source is against SCN, then also thinking about how strong is it against IDC. That's not even considering herbicide traits and everything else that goes into soybean varieties. It's hard.
At least we could ask the seed companies not to produce varieties that are awful.
Yeah.
We did those studies back around 2009. We had 3 varieties. One, the strongest commercial variety we could find, the weakest commercial variety we could find, and one in the middle. And with 3 pounds of soy green, we greened up the weakest variety, but the yield we couldn't correct it. But the middle variety with the soy green, it was fine. And actually, we still got a yield response with the good variety too. If the variety is at least in the middle, but then you have the extra expense of the iron chelate. And I shouldn't just say soy green. There are 2 or 3 compounds that are effective, not just the one that's in the soy green.
And I think this is a really important point that you're bringing up, too, because I think about when I've watched you give presentations about iron deficiency chlorosis, one thing that you talk about on the management side is like, what are the steps that we should be thinking about, or what are the priorities that we should be thinking about? And I think you repeat variety, and variety, and then we start to talk about things like soy green.
Yeah.
You've done the research that shows where we can save yield by applying an iron chelate and where we just can't get up to where the genetics would bring us for being tolerant to IDC. Can you talk a little bit more about like some of that data or what might be helpful to think about?
We have to admit that there's going to be some fields, probably because of salinity, that are never going to be appropriate for soybeans. Any variety will turn yellow if conditions are bad enough. And in fact, wheat will turn yellow. There is IDC in wheat that it's not as common and it's more easily corrected. But I would encourage farmers, as things are maybe a couple weeks from now when it dries out a little bit, there can be IDC in wheat as well, but it's more of a salinity-driven aspect. But again, the farmers have 20 years of experience of growing soybeans now in this part of the world. And so I think they know where they can get away with it and where they can't. In fact, to help Dr. Miranda out, last fall I drove to all of my old chlorosis sites, going back 20 years to try and find her some new sites. And actually, some of those sites aren't farmed anymore. They're in some sort of conservation reserve or pasture, or they've given up. So not every field can be made appropriate for soybeans. I think we have to admit that.
And that certainly, there's a role for precision agriculture in that as well. And we've had conversations about when we zone out a field and we identify those zones where perhaps maybe iron chlorosis is going to be an issue in soybeans. If it gets severe enough, or if you've got even just a severe enough place for salts, if soybeans aren't going to work, maybe that's a place where you want to plant barley or something else.
Well, I should ask you a question, Sarah. In round numbers, in the Red River Valley, what percentage of your work has to do with IDC? It must be a significant part of your work.
I get asked questions all the time about how to manage soybeans from an iron chlorosis standpoint. Percentage-wise, I'm not sure, because one of the questions that farmers first have is how do we identify zones for iron chlorosis? And I'd be curious to know what you think about this, because I think it is different than making zones, for example, as compared to making zones for nitrogen management in corn. There's different reasons why those soybeans turn yellow in different places. And so one of the things we've been doing here at GK Technology is actually using satellite imagery. I asked growers for their crop rotation history so I can pick out just the years of soybeans. And I will look at just those years of imagery and try to identify maybe 2 or 3 images in the season that will really help me understand where the iron chlorosis occurred in the field, and I'll average them together. And then if I can find a couple of years where it's happened and then make zones from that, hopefully we're getting a fairly predictive model for consistent variability of iron chlorosis.
The standard rate of iron EDDHA, I should probably use the generic compound, or soy green or whatever, is about 3 pounds. So do you go with a heavier rate on those areas if it's a more severe?
Yes. So on a whole, a fertilizer like iron EDDHA, and there are differences in quality of different iron EDDHA products. So it does somewhat depend on the quality of where I'm actually going to be recommending that rate. But let's just pull soy green out and say 3 pounds. I will try to have a goal in the back of my mind that we always attempt to try to get close to a 3 pound average rate over the whole field for cost reasons, because it's an expensive compound. But in the areas where we've got more severe chlorosis, I will attempt to apply more. I've applied up to about 6 pounds of soy green in those really hot areas, and it seems like it has actually helped out quite a bit. Now, there are some things that we need to keep in mind when we're operating controllers controllers that with this in mind. If we're going back and using the old powder, the standard 3-pound rate that you're diluting, and you think about 1 pound going into 2 gallons of water, you'd be thinking about 6 gallons per acre for that 3-pound rate, or 12 gallons per acre with the 6-pound rate. So you have to think about how your controller is also managing that in the field. And some controllers can handle 0 rates and some controllers can't.
It's interesting that the very first publication about IDC in Minnesota that I remember was by Giles Randall in Wadena. And back then, they were growing soybeans in 30-inch rows. Then they used cultivation. And so what he would do was they would plant the beans in 30-inch rows, and they just had a drop right on top of the row. And whenever they would drive into an area where the beans looked yellow, they would turn on the switch. And when they would drive out of it, they would turn off the switch. And they'd put on about 2.5, 3 pounds of iron EDDHA. And so it's interesting that the very first publication about IDC basically was a precision agriculture situation.
And that absolutely is a precision agriculture application. And there's lots of guys that are honestly still doing that, where they're just turning on and off the switch. You're not going to be able to do a true variable rate with that. I think there's some better ways to manage the rates. But to that point, at least your variable rating, it doesn't make any sense to apply these expensive iron fertilizers in places where there's no iron chlorosis.
I talked to a farmer once near Pizek, North Dakota. His land was such that you would drive down into a chlorotic area. I mean, he knew from landscape where the chlorosis was. And I don't remember the conversation exactly, but he had the ability to switch from 15 to 30-inch rows on the fly. And so when he drove down into the chlorosis area, he would switch from 15 to 30-inch rows, which would double the seeding rate in the row. And when you double the effective seeding rate on a micro scale, it does reduce the chlorosis.
And that is interesting, because we have a couple of customers that not only are we variable rating the iron EDDHA or the iron fertilizers, but we are also variable rating the seed for that very purpose. We are increasing that seed rate in the areas that are hot with iron chlorosis.
Can we talk about why that is, right? Because it sounds counterintuitive to increase the rate of how much soybean seed we're placing in an area that we know is high in IDC, right? It's like, oh, well, why do you want to add more beans and more money to where you've got more problems? But what is the science behind that? Why can we help reduce IDC in those areas by increasing plant population?
I studied that in the waning days before Roundup Ready soybeans, okay?
So we're going to go back some years.
Yeah, we're going to go back some years, back to the late 90s when seed was cheap. And
those are the days.
Those were the days. We studied seeding rates, and we studied them, in 30-inch rows. You'll have beans this tall with 100 pounds of seed, and you'll have beans this tall with 25 pounds of seed. I call it the Johnson effect because my technician, Brian Johnson, he forgot to trip the seeding device, and he had no seed. And when he came back, he had a double rate of seed. And we couldn't believe how much, at 100 pounds of seed, how much better the beans were. And here's there are several things that could be happening. Chlorosis is water-driven. A lot of water gives you bicarbonate, and bicarbonate intensifies the chlorosis. And so if you got seeds, like an inch apart in the row, they're drying it out. The nitrate that intensifies the chlorosis is being taken up by more plants, so there's less nitrate to intensify the chlorosis. And my personal favorite that nobody else believes but me is the far red reflectance from one plant to another. Plants know when they're being crowded. And what's the term? I'm going to say it wrong. Atoliation?
Oh, etiolation. Yeah.
Yeah, and that is a vertical response to being crowded. It's far red reflectance. It's an auxin effect, and auxins are iron chelators inside the plant. In fact, I wanted to test that. At the greenhouses at NDSU, there's all this shade cloth, the 50% shade cloth. Well, we had some that we were going to throw away because it was getting pretty tattered. We went out in some fields, and we drove in fence posts, and we made pup tents of shade cloth in a field. And so we had 50% shade cloth, and we had open conditions. And where we had the 50% shade cloth, the beans were taller because of how do you pronounce it?
I think it's etiolation.
Etiolation. And we had less chlorosis. And at one site, we also had every soybean aphid in the quarter section. And so And so I also think that if you start to get chlorosis because of soil wetness, and then it turns clear and the sunlight is intense, the beans can really fry from the chlorosis. That was another thing we were testing. You see, IDC is not like any other nutrient deficiency. I mean, if you got yellow corn because of nitrogen deficiency or sulfur deficiency, you put on some nitrogen or some sulfur and it rains, it greens up. Beans are really hard to snap out of IDC. You can spray the heck out of them and not much happens. It's because it's more than just a nutrient deficiency symptoms. There's actually things that accumulate in the plant. You can call them toxins if you wish, that accumulate in the plant because of the IDC. For example, the metabolism of a plant or almost any living organism creates hydrogen peroxide. Photosynthesis, there's peroxide and superoxide produced. There are enzymes that detoxify that. Catalase is one of the most universal of enzymes in metabolism, and that's a heme or an iron enzyme. So it's more than just being a lack of iron. It's all of the downstream things that are effective. That my current theory is, okay, I'll make a bad analogy. If you have a fever because of a bacterial infection and you go to the doctor's going to give you 2 medicines. He's going to address the fundamental problem, which is the infection, right? You're going to get an antibiotic. But you'll probably also get something for the downstream effects, the inflammation, the fever. Now, it might just be Tylenol, but you have to treat the cause and the downstream effects. And so this is why if you've got IDC at the first or second trifoliate stage, it's really going to be hard to snap that out of it. But, there are cases when a farmer will use 3 pounds of soy green and the plants get about this tall and it starts to wear off. Maybe there's chances for a rescue treatment there because you got leaf area to treat. The beans aren't so sick. The growing point isn't injured. And maybe we need to do more than just apply iron. What can we do to help the plants process the superoxide and the IDC? To me, those are some of the future of iron chlorosis work that's out there.
When we were talking about concentrating those plants in a row and talking about growing them tall, and you were talking about the shade cloth and how you can really fry those beans under intense sunlight. Because immediately when you started thinking about that, I was thinking about radical oxygen species in the plant as well.
Exactly right.
When we've got those iron chlorotic situations and then under intense sunlight, is that radical oxygen generation enhanced?
I don't know if anyone's ever done it with soybeans, but people just have clipped off plants with IDC and just extracted the plants with water. And they show that there's an accumulation of hydrogen peroxide and superoxide.
I think it's very similar to like the mode of action for PPOs, applying a PPO herbicide like famecifin over a soybean field or Flexstar. You kind of get, if the plant isn't metabolizing it very well, or you're using a PPO inhibitor that isn't labeled for soybeans, I feel like you kind of see that same symptomology on the plant, right? You get cell disruption, you get like a yellowing of the leaves because there's that buildup of reactive oxygen species and like bad radicals. And like with PPOs, if you've got higher sunlight, you've got more of that activity and more of that damage.
Didn't Zollinger and you, or was it Franzen, do a paper on that?
Franzen and Zollinger did a paper, again, at the tail end of the conventional soybean era, all of these over-the-top herbicides. And if the beans are already suffering from IDC, some of these herbicides are rough enough on the beans. It's like kicking someone when they're down. It's
so interesting because I think that's part of the reason that AgVise started doing calcium carbonate equivalency testing was for that exact purpose of like Zollinger, I think, noticed a response of these higher carbonate containing fields would react more negatively to herbicides that weren't metabolizing over time. And so they were trying to figure out what is that relationship between higher carbonates and this higher crop response.
And it's a really important conversation for now because we've got resistant weed issues. So guess what's back in style again? All of those herbicides that was probably in that paper.
I had coffee with your friend Marcia, and they never got out of those old herbicides. And what's old is new again, I guess. They never got out of that business, and they're doing fine as far as their business goes. Because
just like bell-bottom jeans, it's back in style.
Well, I told my wife if I live long enough, my hairstyle and my clothes will come back in style.
Okay, kind of wrapping this whole concept together of like planting soybeans in like a row, or it sounds like if we're increasing the amount of soybean plants that we've got planted in an area, there's a lot of things that are helping to reduce that risk of IDC growing. not only is it that you're lowering the water table and reducing the amount of bicarbonates that are in the soil solution, you're also helping to protect some of the downstream effects of IDC because you don't have enough iron in the plant. The plant isn't able to build up those enzymes that can help them to break down some of the metabolic processes. And so if there's more soybeans, there's more shade. They aren't as affected by some of the negative things that they can't break down because they don't have iron in the plant itself.
Yeah, people younger and smarter than me are going to have to work on some of these things because, like I say, we still need a rescue treatment. Every agronomist out there does everything they can to prevent IDC, but yet it still hits us. Like I say, if the plants get so sick, so small, it's going to be pretty hard. What if they get 6, 8, 10 inches tall? Maybe there's been a lot of rain and maybe they did things right, but now it's going back into IDC. There still needs to be work on rescue treatments.
Something that I get asked quite frequently by farmers and agronomists is what should we actually be soil sampling? What should a soil test include for trying to identify where iron chlorosis might be occurring and to what severity?
You know, the big picture is, of course, your DTPA test, the calcium carbonate, and the salinity. You know, those are the three. I have a tiny quibble with AgVise in the sense that you can have an electrical conductivity of 0.5 or 0.6 with just because of the clay and the exchangeable cations. You know, but if it gets much beyond that, it's because of elevated salinity. Those are the main factors. There are modifying factors by year. The wetness is a factor. The nitrates are a factor. The environment, you know, like I say, these chlorosis areas are bigger or smaller. There's good chlorosis years. There's bad chlorosis years. And that part of it is hard to predict.
When you say DTPA, do you mean like the DTPA iron test?
The DTPA iron test, yeah. I don't know what else I would be testing for apart from those three things.
Certainly there's confounding things that inhibit iron uptake, but it always seems to me like the number one indicator where you should start on a soil test is the calcium carbonate equivalency, and then take a look at the salts next. Is that out of order in your opinion?
Well, you can have terrible IDC without elevated salts, but if you got the salts, it's going to be worse. You know, I have seen recently salinized soils that didn't have much lime in the topsoil. You know, maybe there was a change in a drainage ditch or something, and something has become salinized recently. But those cases are pretty rare. You know, normally if there's salinity because of soil formation, you got the lime in the topsoil as well.
And especially in this neck of the woods where the calcium carbonate is in the parent material. But if we do run into those places where you don't necessarily have the elevated calcium carbonates, but salinity is there, then you're probably dealing more with a salt issue than an iron chlorosis issue.
Yes, and obviously if the salts are high enough, you're not going to grow beans anyway.
Right.
You're going to have to grow something else.
And that is the perfect place for precision agriculture as well. Oftentimes we're dealing with these salt-affected areas. We're dealing with modified yield goals or change the crop to something that's going to make more sense or plant something different there because it is not worth it to put in all of those inputs into that salt-affected area. Furthermore, especially if you're in prairie pothole country and you're around those potholes, if you soil sample those areas by themselves, a lot of times you'll find elevated nutrients there.
Yes.
And so it doesn't make sense to add more nutrients.
Yes, I mean, if an area has overall poorer yield because of salinity, even in a crop that's not particularly salt sensitive, but you're fertilizing it all the same, you're going to have an accumulation of nitrates and so on. Yeah.
We saw those quite a bit looking at soil test reports at AgVise. Very, very common for some of those like red zones in fields to have 100, 200 pounds of nitrate and a lot of sulfur and even a lot of phosphorus too.
I remember one time when we were working in the lab, and I think you mentioned that iron chlorosis provides a lot of really great job security.
Yes. Yeah. I don't know. Maybe the gene jockeys will put a root reduction gene into soybeans to make the problem. Take a gene or two from barley or something. I don't know, but it hasn't happened yet. They seem to be up to their necks with herbicide resistance and some of these other things. And I should say, pesticide resistance, you two are young. This is going to be a problem for the rest of your careers. You know, you mentioned the two genes for cyst. Well, what's the third? pesticide resistance. Every young person starting off in agriculture, that's going to be a real issue.
It's interesting because when I came into the industry and when I was first learning how to scout crops and make recommendations, the first recommendations that I were making was in purely Roundup Ready soybeans. And, you get your rate of Roundup out there and you put and that was all that was going down.
The good old days.
The good old days. It's just so different. And so a lot of these conventional herbicides, I've had to either learn by working with dry beans or incorporating them as my career has gone on and we've needed to solve something new with, ironically, something old.
I can tell a story about that. It was during the high holy times when Roundup was killing everything. I gave a speech on IDC for the Sinner Brothers group, food grade, right? And Rich Zollinger was talking about conventional weed control. And I can't remember what the question was, but a farmer asked a very routine question. I have this weed and this weed and this weed in my conventional soybeans. And I'm not making this up. Dr. Zollinger, who is a saint as far as I'm concerned, he had to look in his own weed control guide because he hadn't dealt with that for a few years. Yeah, and that's back where we are again. What's old is new.
Just Roundup has been such an easy button. It has been a wonderful roller coaster ride for as long as it's been effective. And I mean, there's still places that it will be used and be good at controlling weeds for, but we're in a different time now.
But is the seed any cheaper?
Oh, heaven's sakes, no. Oh, my gosh.
Too soon. I don't want to talk about that right now.
Too soon.
She just got done planting her crop. Dr. Goose, you have seen so many things over your career. And this is a two-part question. If you had anything that you could peg as your favorite thing in your soils career, what would it be? And if you have anything that you are extremely excited for the future, what would that be?
What was the first question again?
Over the course of your career, what is the thing that has excited you the most?
Boy, I think one thing that's exciting for North Dakota, and this is going to be a very unusual answer, and maybe not one you'd get out of the main station in Fargo. It has been exciting to me to see the development of our research extension centers. I don't know of any other state that has as many high-level PhDs on their experiment farms. And that has been a pretty exciting development. And so, and then the other thing is the development of our checkoff funds. The Soybean Council, corn people, even eventually the Wheat Commission. There was a time when our Wheat Commission, one year our Wheat Commission spent $1 million on lawsuits against Canada and $1,500 for production research. But that's changed now too. I'm not casting shade on them. They did what they thought was best for the marketing of the farmers. But our commodity groups put good money into production research. So between the commodity groups, SBAR, our experiment stations, we have a phenomenal infrastructure in North Dakota for ag research.
I agree with that. And I know Sarah can talk way more about that specific subject, but in my short career, having lived and worked in agriculture in other states, again, over my very short career, I've only seen reductions in other states of the reduction of those field stations, reductions of the number of PhDs and researchers on those stations. It's very different here in North Dakota compared to other places. We are very, very lucky.
It's not an accident, though. As far as I know, and Sarah, you can tell me if I'm wrong, the Dickinson Research Extension Center is a separate bill.
Kind of. There's, okay, so for the audience listening, this audience may or may not know this, but currently I serve as the chair of SBARE, the North Dakota State Board of Agriculture Research and Education. And you can go find out more about that if you Google NDSU SBARE. The way that the budget works is the College of Agriculture is separate from the Ag Experiment Station and Extension. And within that, the budgets are separate, and there are places within that bill. It's all one bill, but each extension center does have its own budget. And so that is very critically important. But to be quite honest with this conversation, it's critically important to North Dakota that we have those research extension centers supported, as well as agriculture research. North Dakota is number one in just a plethora of different crops. Yeah. And that isn't by accident either. We wouldn't be able to have dry bean production in this state if we didn't have that specialty crop supported to the way that it is. The private companies are not going to do the research that supports all of our specialty crops in the state because there's just not enough acres of them nationally to get good return on investment. And so the fact that we've got all of these researchers here in the state that work on all of these crops, that gives us the information that we need to continue to be competitive in the way that we raise these crops. And so it really is something very special that this state has, but we are just incredibly blessed. From my perspective as somebody who has spent time on SBARE, we have been incredibly blessed by the researchers who are here, the faculty and the staff that make all of this research happen. There's a lot of hard work that goes on out in those fields, and we are just so incredibly blessed to have all of the researchers that do that work. I've learned so much about it through my experience on SBARE.
But to get back to my point, and thanks you for clarifying that, the experiment station is a separate bill.
From College of Agriculture.
But in some states, it's all in one huge higher education budget. But in North Dakota, the experiment station has its day at the legislature. And those experiment farms, they have their ducks in a row. They know what they want. They have the local support. It's all very good.
They all have to come in front of SBARE, and they have to tell us what stakeholders come in front of SBARE and tell us what they need for priorities.
Yeah, so it doesn't just happen.
Thank you for your service, Sarah.
It's been an honor, and it's been really amazing. I believe so much in agriculture research, and I believe it so much from our land grant perspective because it provides that third-party independent research that we really need. We would not have the information on iron chlorosis that we've got from Dr. Goose today if it wouldn't be for the overall egg experiment station funding and the checkoff funding. And soybean production in our calcareous soils would just look so much different. So it's pretty neat.
Well, I think that's a really good place to probably wrap up our conversation. We've touched a lot of different corners of soil fertility and crop production here in North Dakota, and it has been an absolute pleasure to have Dr. Goose's expertise and stories with us here on the podcast today.
I think it's really important for us to say a big thank you to Dr. Goose for all of the research that he's conducted over his career in North Dakota. North Dakota agriculture and the way that we think about fertilizers and soil fertility and soil management in the state would just be completely different than where it is today if it wouldn't have been for the work that you've done in our state.
At least on a couple nutrients, that's for sure.
Yeah.
and we bring that up not only because this is specific to North Dakota, but because it is public research, this kind of research gets disseminated out to folks in the prairie provinces, in our neighbors in Montana, Wyoming, South Dakota, Minnesota. This research doesn't just stay here. It covers the whole region as well.
And I want to come back sometime and talk about wheat.
Yes.
Let's talk about wheat on another episode.
We'll do that.
That sounds great to me. Let me think about a wheat pun really quick. Until we wheat again, Dr. Goose, thank you so much for being on our podcast today. Folks, for listening, thank you so much for being here. Just remember that with GK Technology, we have a map and an app for that.
No, I can't wait to get in the fields again.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture, so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.